Class. I'm not implying anyone per, specifically. I'm not, it's like it got dark in here. I'm not throwing shade. It was just an observation. Tree, did you want to take the test? 5. Okay. All right. So, showing a related rate problem. Revolving light located 5 kilometers from a straight shoreline turns at a constant angular speed of 3 rad per minute. What speed is the spot of light moving along the shore when the beam makes an angle of 6 degrees with the shoreline? All right, let's unpack all this. So, walk me through it.
The light is revolving.
Okay.
What is that? That turns at a constant angular speed of 3 rad per minute. So
Okay, that's good. That's important right there.
there's a straight shoreline and then a revolving light. And as it moves, the light, the thing is showing goes like this, follows like the path. So it's asking when the beam makes an angle of 60 degrees with the shoreline.
Ooh, excellent.
Would there be two places that make 60-degree angle with the shoreline?
Turn up your volume.
Would there be two places where it would make 60 degrees? I mean,
Sure, if it's going a different direction, but then it could just be negative, so it doesn't matter.
So,
there's different
are you
perspectives.
talking about like on the left side and the right side?
No, I'm saying top, bottom.
All right. What's the first thing we talk about all the time when I say to do this, to be able to start entering this? What should I start with?
Draw it.
Let's draw this. So, start my shoreline. And then we have my lighthouse. So if this is the shoreline, and then $5 kilometer from a straight shoreline turns a constant rate, 3 rad. This right here. So this right here has to be angle of 60 degrees with the shoreline right there. I'm going to have a theta here. And I know that d theta dt is 3 rad per minute. Okay.
It's asking with what speed is the spot of light moving along the shore when the beam is at 60 degrees. angular speed would be GRD.
Or d theta.
Theta.
Yeah, d theta. Because we used r for the radius quite often.
Yeah, so it's,
Yeah, and I don't want to try and do that because that I'm talking about an angle that's changing over time. Anything else I have?
We could find theta.
Oh, I could find theta. What is theta supposed to be?
30.
Why is it going to be 30?
Because that angle's 90 and then angle 60.
Okay. Now, do you guys recall motion of the circular angular speed w is defined as the rate of change of the central angle theta of the circle with respect to time, where w, which is that, is d theta dt, where theta is measured in radians. All right. So I'm looking for the rate that the x is changing here, right? So that means I'm looking for what? Dx dt.
So we're gonna use that angular speed equation whenever we turn the
No. That actually went with this right here. D theta dt is the w, which is angular speed. But I threw it out there because you guys, those are things that most people forget, since it was some of the stuff that you guys did in trig, which was supposed to be last year. But again, I try not to emphasize the fact that I hate it when teachers say, "Oh yeah, you're supposed to already know that." Well, if you forgot it, then it's a refresher. It might have been a year. Trust me, I can't remember everything every day all the time. Every time Tree starts talking to me about Unit 7, I'm like, man, I haven't touched that in like a year. So yeah, I gotta look at it real quick. All right. So I know that my problem is going to have here, I need to have this in my problem. And I should probably have this in my problem, right? And what is that? It could be Pythagorean theorem, but I don't want to use it.
Oh, because we have to find.
Yes, because we need to find a couple things here. Tangent, very good. I put the right angle right there, hoping you guys could actually see that. So if it's going straight away to here, that means this one over here, the red line, is my hypotenuse, and I'm not including that into my formula. I don't need that. That's going to be arbitrary information. But we can go through and actually find all these things. So I know my problem has to have two things in it. It has to have the theta in it, and it has to have this x in it. So since I know that these two things have to be in my problem, they're going to be variables. And if they're variables, then I'm going to get a d theta dt. I'm going to get a dx dt. That's why looking at these, I know I need to have those in my problems. So I'm going to set this up. Morning. No, I don't have anything. So no loaves. All right, so I'm going to have tangent of theta is equal to what? X over 5? Now, 5 is a constant, isn't it? That is a constant. So there's no variable on that one right there. So that one would be my adjacent in my tangent formula, wouldn't it? Okay. So in my tangent equation I set up here, I can do that.
Then x just equals 5, 10 div. X equals 5 times 10 div.
I could. That would be a product rule, right? Do I want to do that? Do I need to do that? Say no. I don't. Did we learn how to do implicit? Where we can have variables on both sides now? All right, what's the derivative of tangent? Secant squared. Anything else I'm missing? Did I take the derivative of theta? Yes. And so therefore I need to say what? D theta dt? Because I'm taking the derivative in terms of time now, right? Equals. So it's basically take the derivative 1/5 x. Or I get 1/5 dx dt. Okay, let's see what all we know. Multiply both sides by 5. So I'm going to end up with 5 secant squared theta d theta dt is equal to dx dt. Now, there is an issue, there is a problem, there is a complication on my board. Can someone tell me what that is?
Both d theta dt. You want both d theta dt and dx dt?
No, not really. No, because we're going to have those. We're going to get those. Angel, what's the problem with what's the information on my board?
I'm not
sure it's right, but the 1/5 means the left degree.
No, that one's okay. Go ahead.
Or we're supposed to isolate d theta dt so we can set equal.
No. My work is correct, but there's a problem, something on the board that we haven't addressed yet.
The squared.
The what?
Squared.
Nope. What about the angle? Gotta work on your volume here.
We haven't put it in the equation.
Nope.
It's in degrees instead of radians.
Yep. We have both a radian and a degree. My rate, my d theta dt is in rad per minute, where the angles that were given to me are in degrees, aren't they? So we got to do a little bit of conversion. Five secant. What's my theta going to be now?
I6.
What is 30 degrees? 5 or 6?
Yeah.
Okay. A little bit louder. Okay, I'm sorry. All right, with that secant pi over 6. Secant is the reciprocal of cosine. What is cosine at pi over 6?
Is it
Rad 3 over 2. But if it's secant, that means it's the reciprocal identity, so it becomes
2 over rad 3? Or would it be
2 over rad 3. 2 over rad 3, that's correct.
and then it's squared?
Yep, we still got that square. So when we square it, I'm going to get 4 over 3, then times 3 cancels, and then 4 times 5 is 20. But what is it we're talking about here?
But what happened to the 3? He would still be there. Oh, the 3. So because he did.
It's 20 what?
No. It's RTX 60, which is the speed.
What's the units for my x? Not radians, kilometers. X, okay? So we go off on this side over here. This is in kilometers, right? So if that's in kilometers, that means that all my distances are going to be in kilometers.
Per minute?
Now, walking through these problems, yes.
Back to what I was saying about there being 2 6-degree angles. What happens when the light would pass the lighthouse and go this way, and it would also make a 60-degree angle?
It'd be at the same thing. So, you're talking about on the left side of this, right?
Yeah.
Okay, either way, that's the rate of change. So, yes, one's going to be a positive, the other one's going to be negative. This one right here should be a negative, shouldn't it? Why should it be a negative? It's getting smaller, right?
And in this case, if it was the other side, it would be getting bigger.
Yep.
So they would be different, just one would be positive.
Yeah. One side's positive, the other side's negative. It didn't say which way it's going. But either way.
So then how can you assume that this one's negative?
How am I assuming that this one's negative?
Yeah.
See this right here? It's going this way, and that's just how I drew it.
Okay.
Yeah, that's just how I drew it. If I drew it going the other way, it would have been a positive. And I'd still have all the same values. Okay? Did you have your hand up for a second? Utter questions? Utter madness? Utter chaos? No? I hope so. All right, now, questions, concerns, complaints, conspiracy theories.
So on the AP test, would they be more specific?
Yeah. And usually, like this right here, it would give you something that tells you, that it is, this side or other, or, it's, yeah. In this case right here, it didn't. Just the same way I've been drawing it all the time. Watch, I go to the book and it's actually the other side. So, yeah. Anyway, all right, that's it. Like, share, and subscribe. And you have approximately 2 weeks and a day. No, 2 weeks, 2 days. to get your homework done.
Which is, what is it, 4.1, right?
January 7th.
Yes. Can you go back, can you tell us what the homework problem starts?
Yeah, the homework problems? Yes.